Sathyabama Institute of Science and Technology.
Greetings to everyone. This is Dr. Sheema, Assistant Professor in the Department of Computer Science and Engineering at Sathyabama Institute of Science and Technology. Today we are going to discuss about the topic conversion of infix to postfix in data structures. Before getting into that topic, we need to understand some glimpse of that concept. Evaluation of arithmetic and logical expression. Here, we're going to convert the parsing, the arithmetical and logical expression from one method to another method. So, this kind of thing is called as parsing. So, parsing is a process analyzing a sequence of symbols or set of symbols which can be narrated either in a natural or a computer language. It should be formed according to the formal grammar. The extension of parsing is a expression parsing. It's about evaluation of arithmetic and logical expression. So this is the expression. Example, a plus c explanation d minus e plus f star g. This is the example for expression. The way to write the arithmetic expression is called as notation. This kind of notation can be written in three different formats. So without changing the essence of the output, we can provide the equivalent notation. So these are the three notations: infix notation, prefix notation and postfix notation. So in order to perform this notation, we require two important things. One is operator and another one is operand. So operator is nothing but symbols which state plus, minus, asterisk and a slash, which helpful to perform one analysis or to do some operations. And operand is nothing but it's a variable which holds a value of that variable. For example, here we have declared number equal to 5. The number which carries the 5 value. So whenever you include this kind of variable declaration in the program, that will be reflect entire program. So let's see the notation one by one. First one was infix notation. So in infix notation, the operator should be placed in between to two operands. So here A, B, C are operand and minus and plus are operator. So using this kind of expression, human can easily evaluate the operation and perform some analysis, but computer does not do the operation easily. If you go with this kind of design for your algorithm, you will not get a proper output, and also it takes a time complexity and it's also cost effective. So in order to avoid this complexity, we can go with the prefix or postfix notation. So this is prefix notation. Here we can see the operator is placed before of that operand. So asterisk and plus are operator, A, B, C are operands. So this kind of notation is also called as Polish notation. This is the postfix notation. The operator are placed after the operand. So this is called as reverse Polish notation. So whenever we are doing an operation, compared with the infix, we can better go with the prefix or postfix in order to get a better accuracy and delivery. These are the examples for notation for infix, prefix and postfix. Here in infix, the operators are placed in between the operands, and in prefix, the operators are placed before the operand, and in postfix, we can see that operators are placed after the operand. So in order to perform the notation in better way, two things are mainly we need to consider. One is precedence and the next one is associativity. So what is precedence? In the sense, we are giving priority to the operator. So based on the priority, it will perform the analysis. What is associativity means? If you have a same precedence of operator in your design, you cannot, you need to perform the operation from left to right. So these are the two main things we is required to resolve the problem. Okay, in this example, A plus B enclosed with the brackets. So it means that we are giving priority to the operator. So here A plus B into C have mentioned, and here B and C are enclosed with the bracket. So that we are telling the compiler to give priority to the bracket one. And associativity, whenever you have a same precedence, here a different precedence is there. For example, if you have a minus is there, means you need to resolve the problem, you need to perform the problem from left to right. So this is the table for a operator precedent and associativity. Here the operator explanation have the highest priority, and the division multiplication have the second highest one, and addition and subtraction have the lowest precedence. Next we are going to convert the infix to postfix expression, and this is the expression. Within a bracket we have given u plus v slash w asterisk. Within the bracket we have mentioned x plus y minus z. So in order to convert these things, we need to follow major 4 rules. What the first rule is, the operator priority should be given. So based on the priority only we need to resolve the thing. And the next one, no two same precedents cannot be retained in the expression. The next one is, if you pass some priority based operator, the lowest priority cannot tolerate with the highest priority. So immediately highest priority will be sent to the postfix or a stacked column. The next one is, operator with the 2 brackets can be stacked. Whatever operator come up with a bracket, that particular operator will be stacked with the postfix operation. So these are the major rules. Once we get into the problem, we can easily understand the rules. So now we are going to solve this expression from infix to postfix. See, here all the operators are enclosed or placed in between the operand. So first we are going to take one by one. So this is called a parsing. We are going to analyze and process one by one. So first we will take the operator bracket here. So 3 things are required to perform the thing. One is the symbols that and all will be listed here, and this stack column will hold the operator, and the postfix column will hold the result of the thing and the operand. So this bracket is the operator. We are going to send this operator to stack column. And what the next letter? U. So we can take the U in the symbol 1. So U. So U is the operand. We need to send it to postfix 1. So along the bracket also will come along with the thing. And next we are going to take a plus value. So along with the bracket, plus also coming. So what's the next value? V. So V is placed. We need to send this V to postfix 1. So we got the answer along with the U. And what's the next character? Slash. So when you put slash here, slash will accompany with bracket and a plus as well. And the next value is W. So W we need to send it with postfix. So you will get the result UVW. The next one is asterisk. So now the asterisk will be sent to stack column. Okay, here we have a one confusion. Since asterisk and slash are having the same precedence, what we have seen in the last slide. So this higher priority will not tolerate with the lower one. So this slash will be sent to the postfix column. And what's the next? Slash. So slash is added to the stack column. And what's the next value? X. X need to send to postfix. What's the next value? Next character is plus. Plus should be added with the stack column. And the next one character is Y. Y should be added with the postfix. The next one is close bracket. So whenever you have a operator along with the 2 brackets, that will be sent, that particular operator will be sent to the postfix 1. So now we are going to send the plus along with the Y. So the result of this postfix, and next value is minus. Here minus is the lowest priority and asterisk is the higher priority. So that also not possible that. So asterisk will send to the postfix expression. So this is the result of this line. And the next one is Z value. And one more here, plus minus both are same precedence. So that's not also possible. So we are, as per the associative rule, we are sending this plus operator to the postfix notation. Now we have sent it, and what's the next value is Z. So adding z, so obviously z will be added to the postfix one. So result of this expression, z is added, and the last one is close bracket. So close bracket is come up with the two brackets, that also it's send it to the postfix notation. And here one thing you need to consider, that is no brackets will be added in the postfix one. So this is the result of this postfix expression for this infix one. So this is the infix operation. Using that step, we have converted that infix into postfix expression. So this is the result of the postfix expression. Thank you.